Welcome to qnawire.
Here we're going to have that mass on a spring with a constant equal to k is going to have an initial position at time equal to 0 of x0 equal to 0, and it is going to have an initial velocity at time 0 equal to minus initial velocity minus b0 over here, going onto the negative x-axis. With this information, we want to determine what are going to be the values of a and b on the general solution of x of t equal to cosine omega t plus b times sine of omega t. So first of all, we know that this is going to be the corresponding value for x of t, but we also know that the velocity as a function of time would be equal to the derivative of x as a function of time with respect to time. So in this case, we would get that applying chain rule minus a times omega with sine of omega t plus omega t plus omega times b cosine of omega t needs to be equal to my initial velocity. So from the first condition, x at 0 needs to be equal to 0, and this needs to be equal to a times cosine of omega times 0 plus b times sine of omega times 0. For all possible times, the value of sine would come to 0, so that means that a times cosine of 0, which is a, needs to be equal to 0. So on this equation, the value for a should be 0 coming from the first condition. Now, the value for b is going to be determined by the condition on velocity. So we know that velocity as a function of time at time 0 needs to be equal to minus initial velocity, and this needs to be equal to omega times b cosine of omega t. Replacing instead of value of t the value of 0, and remembering that cosine of 0 is going to be equal to 1, we know that the value for b would be equal to minus b0 over omega 0. So with this, the general equation of motion that we're looking for is going to be equal to x as a function of time is going to be equal to the value of b that we determined to be minus b0 over omega 0 times the sine of omega times t. Now, in terms of the plots, first of all, we're going to plot x as a function of time with respect to time. In this scenario, I'm going to take advantage that I already know what is kind of the solution over here. So we're going to draw the time axis over here, and we're going to determine that the values over here of the amplitude of the movement is going to be equal to b0 over omega 0. These are going to be the maximum and minimum values corresponding to this function. As you see, since sine of omega t is a function that goes from minus 1 to 1, then the amplitude is given by the factor minus b0 over omega 0. Okay? So essentially the amplitude is going to be b0 over omega 0, as I mentioned before. So in this scenario, the first period of oscillation, we're going to be going on the negative x-axis over here, and we're going to have a plot as follows for x as a function of time. The x max value would be equal to b0 over omega 0, or over omega in this case, and the value for x minimum would be equal to minus b0 over omega 0, the normal frequency of this harmonic oscillator. And for c, in this case, we want to write down an expression for velocity as a function of time, which we already kind of did over here. So we're going to get that velocity as a function of time. So over here it was minus b0 would be equal to omega 0 times b times cosine of omega t, right? Coming from this relationship. So in this case, replacing the value for b, we're going to get that the velocity as a function of time is going to be equal to minus initial velocity times the cosine of omega t. So again, since cosine is going to go from minus 1 to 1, the max velocity would be equal to b0, and the minimum velocity would be equal to minus b0. And in this case, our plot is going to change a little bit. This is velocity as a function of time. We're given that we are initially at the maximum value over here. This is time. So what is going to occur is that this velocity is going to decrease, goes through 0, then it's going to increase and continue the oscillating motion, and so on. So with that, it would be all. And over here, for example, in the x as a function of time graph, we could continue, and the period of the motion would correspond to the time interval in between two minimum or in between two maximums, okay? So this would be the period for the motion that we're capturing over here. And in this case, the information of the points at which the velocity is a maximum or a minimum, these are going to correspond to points for which the value for x is going to be equal to 0. They are going to be passing right through the equilibrium position. And all of those times are going to correspond for either time equal to 0, or for times equal, or for times corresponding to n times pi over omega. So, for example, over here times is equal to 0. Over here, the time corresponds to the first period of oscillation, so this would be pi over omega. Remember that if you replace this value, you're going to end up with cosine of pi or cosine of 180 degrees, which is going to give you the corresponding value. Over here on the maximum, now we're going to get 2 pi over omega and 3 pi over omega, and so on and so forth. And with that, it would be all. Thank you very much, and have a good one. Remember that this is going to be because cosine of n times pi is going to be either +1 or -1. And now with that, it would be all. Thanks, and have a good one.